D2DNY, Real World HVAC Simplified. And now in this video I'm going to be showing you how to use your manometer to check your inlet gas pressure, adjust your pressure regulating valve, your inlet pressure regulating valve or PRV, and also adjust your gas valve so that you can have the right operating pressures on the manifold or the burners. All right, so that's happening in this video. As you can see, this is a commercial heating furnace. It's a brand new startup. Especially in the commercial world, if you're doing a startup, you're going to want to make sure that you have the proper incoming gas pressure. Right, incoming. That's the incoming side. You can see I'm tapped in with one of my pressure sensor from my manometer. I got 2 ports in here. It's a 2-port device. And the other one is on my burner, the burner pipe or the burner header pipe. But anyways, that's that. Before we get into the video though, I want you to go ahead and subscribe if you haven't subscribed, and smash that bell icon so when I upload videos like these, you get them right away. All right, so usually with the gas furnace, the manufacturer will send the specs, or you can just look on the gas valve to see the ratings on the gas valves. For example, in this case, you can see that the input gas supply pressure, this is the minimum permissible, right? It's 5 inches of water columns, and the manifold pressure, which is over here, that is supposed to be 3.5. Now this is a modulating furnace. This the heating system can modulate. So this is the main gas valve, and this is the modulating gas valve. So based on how much demand between 0 to 100, this main valve will open, and then this valve will modulate and control how much flow of gas enter the burner. Now obviously if you're at 50% modulation or 50% heating PID or 50% heating demand, you not only get 3.5 is at 100% PID, 100% demand of heat. All right, so yeah, let's show you how you gonna adjust your incoming pressure or incoming PRV. So you have this cap that was on here, you know, so I just pulled it off with a flat screwdriver. And once you take that off, this same screwdriver don't know if you could see that, but it's a flat, it's rather dark in there. Hold on a second, let me get some light on that. I turn the lights on this thing right now. Yeah, there it is. Can you see it? There you go. That's it. So that's how it is in there. There's a little gasket right here that was on here. Just make sure you put that back so that there's no water enter into the thing, into the pressure regulator. You know, put them back together when you're done. Okay, so there you can just put that in there, screwdriver, and you can see that's my incoming gas pressure right there. I think this is a bad place for my tool, so you guys ain't seen it. So let's just move it over here, or even right here. That's better. So you can see I'm at 9.4 inches of water column. That's my entering gas pressure. And as I turn this, if I turn this PRV, if I turn it down, or I would say clockwise, so I'm going that way. As I turn it down, you can see what's happening to my water column, my pressures, right? It's going up. Now this furnace, it doesn't say it here. It gives you the minimum, but the maximum on this, it's in the literature or the booklet that came with it. The maximum is so let's turn it back the other way, counterclockwise. The maximum is 13. The maximum allowed water column is 13. So to turn this counterclockwise on my PRV, you can see my my incoming pressures is dropping, and so did my meter. It turned off. Okay, we're back on. Right, so as I turn it counterclockwise, so as I turn it out, I back it out. Right, you can see that as I do that, I'm dropping in incoming pressures, right? But what I want to do is leave this at about 9, just in case for surges and fluctuation. Right, that's where I want to leave it. Yeah, right there. You know, just in case the incoming, the main dropped a little bit, we're still good. It doesn't affect my manifold pressures. So now I am going to fire up. Now the same thing, the same concept that applies here with this PRV is the same setup as on the gas valve, right? So on the gas valve, it's a smaller adjustment cap and adjustment screw, but it's the same concept, right? Again, if you like this video, comment in the give it a thumbs up and comment on it in the comment section if you have learned something. Again, give this video a big thumbs up, because then other people in your situation, on YouTube, they will be able to see this video, because YouTube will recommend it. So yeah, so here we are. Get some light on that. So it's the same thing, but it's a smaller version. Now on the gas valve, you have the I adjustment. This is the high fire, because it's a 2-stage gas valve. You have high and low fire in this gas valve, right? So the 2-stage gas valve. So you have the high, so right here, the arrow. Naturally, no, this is the flow. But the high is this adjustment right here, regulator adjustment, and over there you can see it says low. Obviously, right? Boom, that's one right there. That one right there, I didn't remove the cap, the protective cap, but for the I fire, I have the cap removed, and here's the cap. Same thing, but it's a smaller version, right? Okay, so now I can still use the same screwdriver, and I'm gonna take the bit out, because we don't need to have this whole thing. It's a tight space. So yeah, I could take this and I could just stick that down in there, and it fit. Yes, it does fit. It gets a bite. I could turn that. I could turn it. And the same thing, you turn it in, that's going to increase your pressure, and turn it out to decrease. Let's get this thing fired up, and then we're going to switch to the other sensor, which is this sensor right now. Sensor number 2, that's over here. And sensor number 1, it's over here. This is number 1. That's the incoming gas. This is the incoming gas line right here, right around from here. Boom, incoming gas. And that's pretty much where that is. Now, also right here, that's the outlet. But I prefer to go down in the manifold, to get my pressure readings. But you could go right here as well. If you don't have any taps on your manifolds, which almost never, that's the case. There's always going to be a tap on your manifold, but you could go right here. All right, let's go fire this puppy up. So like I said, this is a modulating furnace. So I'm going to go to high fire. So with that, I'm going to make this 100%. Right, eating over right 100%. It's reading 0.3 inches. I could ignore that. I could zero it out. Here we go. And you can see here, go back onto the main. So we had dropped 7.8, right? You see that? We dropped to 7.8. That's hence the reason why I build it up to 9, because I want to have some buffer. All right, so boom, because the minimum is 5. So you can imagine when other units turns on and there's a high load demand, you want to have some buffer, right? You don't want to have everything set exactly, especially to the minimum. Like you want to go like in between the highest and the lowest. So the minimum is minimum is 5, maximum is 13. I'm looking to stay anywhere in between 5 and 13, preferably on the higher end. All right, so let's go back to the other sensor. We're at 3.9, right? 3.4. Wow. So I'm gonna have to back this out. I'm gonna have to counterclockwise turn it out. And as I turn it out, you can see my manifold pressures is dropping. And remember guys, what do we need? We need 3.5, right? That's what we need. Manifold pressure is 3.5. So I'm turning this counterclockwise. And as I turn it, you can see my pressures is dropping. Right? Almost there. Boom, 3.5. Now if I was to turn it, if I wanted to increase my my manifold pressure or the gas valve outlet, I would have turned it down that way, clockwise. Same concept. And now if I put this valve on the first low fire, first stage, then I could adjust this the other side over here, right? Same concept, low fire and high fire, right? You turn in to increase and turn out to decrease. But out of curiosity, let's see what it looks like on a low fire. Let's go to 50% on the heating PID and then see what we got. Pretty cool, huh? I got the flame burning nice. Let's look at the flame. Let's check the flame check. Yeah, it's going through nice. Such a tight little furnace. You can barely see up in there. But you can see though. Alright, let's go put it on 50%. And even we can go like even 40%, right? To make sure that we're going to be in low fire, or really low fire. Let's go 50%. 50. I keep bending my thumb like this, or my index finger like this, because these gloves, that's how they work. If you want to touch your phone screen or your smartphone screen, you use your knuckle, your index knuckle, and you can touch your phone screen. So I'll keep doing this every time I'm trying to push some buttons down. It's crazy, right? Boom. So bring it down to 50%. So we could do 75%. Certainly it's going to drop, but I'm curious to see if it's going to go half at 50%, which is low fire. And the burner controller takes care of all of this. This controller, it sends out, at 50% it sends out 5 volts to the burner controller, and the burner controller does the rest. As far as the low fire, high fire, and the gas valve, and then the modulating bit of it. It also the exhaust fan. I don't know that sound of this one too, right? That humming. But the exhaust fan, or maybe that's the exhaust fan controller. But the exhaust fan, that's 2 stages as well. A low and a high speed. But let's look, we're at 1.7 low fire. So if I really wanted to, I could adjust the low of this valve right here and make that 1/2 of the high fire, which is pretty logical. But should I do it? I don't know. But you have two separate airflow CFM. The maximum is this one, and the minimum is this one. And this fan is right here is 2 speeds. So right now it's running lower than before. And look at the flames. They are smaller flames. Yeah. Let's see what's going to happen if I was to close the gas valve. All right, so we're off, and I'm gonna zero this out. Zero it out. P1, 0. Zero it out. 0. Come on, man. 0 out. All right. So it's trying to like. It's trying to relight. It's trying to spark, but nothing is happening because I got the valve closed. All right, so let's reopen the valve. Oh, this spiked up. See? So there was a bit of a spike. You see that initially when I opened the valve, the PRV spiked. But we back down now. You can see we are at 7.2, and that seems a little bit lower than what I said. So again, that's the reason why you don't want to have your PRV set up to the minimum. You want to find out what the maximum is, and stay closer to the maximum set point. You know, just give some flexibility. You're better off staying closer to the maximum set point, simply because on a cold day when there's high demand, the gas pressure will drop. You know, usually that's what happens. All right. So yeah, boom, boom, boom. Where's that now? Let's go to the other one. Yeah, so we are 1.48. I'm not even gonna mess with that low fire settings. I'm just gonna leave it at that. Let's put it back to high fire, and I'm gonna close this video off. Let's go back to high fire. Let's see if we can go even lower than that. We can go to like 25%, right? It's gonna be even smaller flame. This is a modulating. Let's see if we get lower pressures on our manometer. If I go to like 25% heating. So that's how you use your manometer. That word always ties my tongue, man. Yeah, 25. So the fan is gonna run. I don't know if does the fan slow down if I go to 25? But yeah, it does show right here on my tool. Yeah. Stock pressure is down, man. Manifold pressure is down. And my flames dwindled. It's a modulating furnace for you, baby. Alright. So we go to, that's a smaller flame. The flame is tiny right now. Tiny. The furnace in your home can't do this. This is a commercial furnace. So yeah, you got 2 airflow switches because one is for high fan, one is for low fan. So there's 2 of them. And then again, the controller over here takes care of all that. This is where your signal come in. Right now you're getting, for 25%, you're getting 2.5 volts DC coming here. All right, and this does all the controlling. And then here's your ignition module. Ignition control module, that's a fan board that controls the speed of the combustion motor or induction motor. Furnace exhaust fan, fluid exhaust motor, whatever you want to call it. Many names. All right, yeah. So I'm gonna go to 100%, and I'm gonna close this off. Boom. I mean, if you guys are here, if you're still here, you're special. So I'm gonna do this just for you, right? So I'm gonna go down, and then by going down, I could go back up right quickly. Quickly. Oh crap! I go past it. So 100%. Voila! 3.15. But I'm not touching it. I'm leaving it exactly there. It goes around, comes around, and look, you see my supply gas dropped a little bit, ain't it? right? So yeah, hence the reason why you want to leave your supply, like I said, not at the minimum. If you're at this, if you're coming in, if you're entering at 5, you're gonna be in trouble. It's gonna be a struggle to maintain proper manifold pressures if your inlet gas pressure is at the minimum, because at any given moment that will fluctuate based on load and supply and demand, you know what I'm saying? So that's what it is. All right, so back over there, that's that, and the tool just turned off. That means I'm gonna close this video off.